Right, good day everyone and welcome to the discussion of Book 1, Proposition 8. If two triangles have the two sides equal to two sides respectively and also have the base equal to the base, then they also have the angles equal, which are contained with the equal straight lines. So with this figure, these are our given. So we can say that angle AB here is equal to angle DE, this angle. Okay, and we also have angle BC equal to angle EF, our second set of sides. And lastly, we have the bases, AC equal to DF, the third set of sides. So if those corresponding sides are equal each other, then we can say that the angles contained between them are also equal. So using this figure, then we can say that angle BAC, this angle here, is equal to angle ADF, this angle. And these two angles are contained between the same set of sides, AB, DE, and the third set, AC and DE. So the same set of sides. And this angle are also equal, these two angles. So we have angle ABC, this angle, equal to angle DEF, this angle. Okay, and these two angles are contained between the same set of sides, ABDE and BC and EF. And lastly, angle BCA, this angle here, is equal to angle EFD, this angle here. And these two angles are contained between the same set of sides, the second set BCEF and the bases, the third set AC and DF. So we can then say that it's possible for angle BAC not equal to angle EFD because we are not comparing two corresponding angles because these two angles BAC and EFD are not of the same set of sides. So again, class, this theorem, this proposition 8 is also being called as the side theorem for the triangle congruence. So now let's move on to the proof. For the high-level framework of the proof, we are just using the parameters and arguments of proposition 7 in showing that we really cannot have a scenario that would, a negated scenario that would be true. Okay, the negated scenario or the hypothesis that is opposite to the proposition will lead to some statements that do not make sense. Okay, so this is now our figure for the proof. So we have triangles ABC, we have triangles DEF, that's triangle B, and we have triangle AGF. Okay. By using the empirical truth of proposition 7 that by having one vertex of triangle B, so that's D, okay, not coinciding to triangle A, not coinciding to point A. So this is the scenario, the figure. We have G not coinciding to D and not coinciding to A. Having this scenario, we really cannot have the same set of initial or terminal side for this angle. Okay, the length of these sides produced by vertex G would be of the same length, and the angle of these two new sides here would definitely be different from the angle of EDF and BAC. So the question here, by having this scenario that would negate the proposition having sides EG and GF not equal to AB and AC, can we say that, or can we have angle AGF that would equal to EDF and BAC? Because if yes, then the proposition 8 must be invalid. But we really cannot have an angle EGF that would be equal to the angle here in B and the angle here in triangle A. Okay, and knowing that in creating a scenario that is not aligned and consistent to proposition 8 would lead to some arguments that do not make sense, then we can say that proposition 8 is empirical, is really valid and true. In other words, class, that in falsifying a certain proposition, like proposition 8, we have to have an attempt of creating a scenario that would make it invalid. So we created a scenario here, EG and E and GF not equal to AB and AC, but we have not able to produce an angle AGF that would be equal to angle BAC, because as shown in proposition 8, the sides of different lengths produces or produced an angle different and not equal to angle BAC. So that's the proof for proposition 8. So thank you so much for watching the video, and I'll see you all to the next to the discussion of the next proposition. Thank you.